This video reviews how to use positive and negative signs when dealing with motion equations. So just to be clear, if you call up positive and down negative, or if you call up negative and down positive, then the calculations for velocity, acceleration, and displacement will have the same magnitude and have signs that represent the same direction. So we're going to further explore this idea through this problem. A ball is thrown directly up at a speed of 7 meters per second off of a cliff 9 meters above the ground. How far above the cliff does the ball go, and what is the speed of the ball at 1.5 seconds? So we're going to do this calculation twice. Once using up as positive and down as negative, and another time as calling up as negative and down as positive. So first let's fill in our table. So we know that the ball was thrown up with a speed of 7 meters per second. So this gives us an initial velocity of positive 7 when we call up positive. At the peak, the velocity is 0 meters per second, and the acceleration points down because it's gravity, so we know we have an acceleration negative 10 meters per second squared. Next, let's fill in our table on the other side, where we're going to call up negative. So if up is negative, we know that we have an initial velocity of negative 7 meters per second. Our final velocity is still 0 meters per second, and our acceleration is down still, which is now going to be a positive 10 meters per second squared. Okay. So, in order to solve this problem, we're going to need to find t first. And we can use that through this equation, v equals v naught plus a times t. When we plug in our variables, we find that time is equal to 0.7 seconds. Now, we can solve for time again on the right-hand side, where our directions are switched. And we find that the time is still 0.7 seconds. So remember, if you ever find a negative time, you've made a mistake somewhere in your assigning of variables or calculations. So next we can use our values to solve for our delta y's. Okay, so we are going to use this equation, delta y equals t divided by 2, v naught plus v. And when we plug in our values and solve, we see that the delta y is 2.45 meters. So this means that the displacement was of magnitude 2.45 meters in the positive direction, which in this case was up. Now let's find the delta y for the second case. So when we plug in our values, we get a displacement of negative 2.45. And this is okay, because this tells us that there was a magnitude of 2.45 meters in the negative direction, which in this case is also up. So essentially, these two values give us the exact same information. Neither one is wrong. Both of them are correct. Now let's answer this second question. What is the speed of the ball at 1.5 seconds? So let's fill in our tables again. We know the initial velocity on the left, where up is positive, is going to be 7 meters per second. We don't know the final velocity. We know acceleration is down, so gravity is going to be negative 10 meters per second squared. And our time is 1.5 seconds. Now on the other side, we say that the initial velocity is up, which is in the negative direction, so we have an initial velocity of negative 7 meters per second. Our acceleration is down, so we have an acceleration of 10 meters per second squared, and a time of 1.5 seconds. Now we're looking for this final velocity, and we can find that using our v equals v naught plus a times t equation. So when we plug in our variables, we get that there is a velocity of negative 8 meters per second when the ball is traveling at the time 1.5 seconds. All right. So this means that it's traveling at a speed of 8 meters per second in the negative direction, which is on the way down. Let's solve for velocity then again with our second set of coordinate systems, where up is negative. So when we plug in our values, we get a velocity of 8 meters per second. So this means that the ball is traveling at a speed of 8 meters per second in the positive direction, which is down. So notice that in both cases, we both get the same kind of answers. Our answers are telling us the same kind of motion.